Describe the column spaces of these particular matrices. Okay, let's start with A. What's a column space? A column space is given by the following: the matrix A times the column matrix. So I'm starting with A here. So this is 1 2 0 0 0 0 and x1 x2, and so this is a 3 by 2 and this is a 2 by 1. So if we multiply this, we get a 3 by 1. So this is x1. So the way we multiply matrices, I've discussed this in another video. Hopefully by the time you get here you know how to do that. Row times column. So this gets us x1 plus 2x2 on the first one. The second one will be 0 because the row is 0, and the third one will be 0. So we can see that the column space here is a line, and it only has, if we want to think of the first axis as the x-axis, the first component as the x component, we could see that this is a line on the x-axis. So all the combinations of the elements on the x-axis. So therefore the answer here is line on the x-axis, because it doesn't have any second and third components. You could think of those as y and z components. It's missing those. Okay, let's go to B. B will do the same thing. So the column spaces is given by bx, column matrix x. So we got 1 0 0 2 0 0 and by the way, in A you could see that these two vectors, the column spaces, the column vectors of A only have components in the x, so it would make sense that we get a line on the x. x1 x2. Back to B. So now multiply them, we get x2 2x2, and the third row is 0, so we'll get zeros here. So we can see here, wait, did I mess up? x1. This is x1. Okay, so this, you could see that we have components in the x, we have components in the y, we don't have components of the z. So this is basically the column space of B is the entire xy plane, all the linear combinations of these xy components with z equals 0. So this would qualify as the xy plane. That's the column space of B. Okay, let's go to C. C is let's see, we have 0 0 0 here. So 1, so it's gonna be CX, and C is 1 2 0 0 0 0 times x1 x2. So we get x1 2x2. The third row is 0, because so we get 0 here. Okay, so here this is given by x1 2x2 and 0, which by the way is the same answer we got for the first one, for B. However, since here we have the vector 0 0 0, the second column is 0 vector, you have to contain 1 2 0 0 0 0 and all the multiple vectors of 1 2 0. Because if C is 0, you get 1 2 0. So basically this is a line in the xy plane. So line in xy plane. So it contains all the vectors, let's say m 2m 0. That does it.